All right, today we're looking at outliers and modified box plots. So we looked at box plots yesterday, but there's one other kind called modified box plots, which have to do with the outliers when you have outliers. One more caution, we've done this caution several times. When you analyze data, always identify the outliers and consider what their effect is, because they can be really substantial. They can really mess up some data, just one big outlier, especially if there's more than one, it can really influence your data. So really look out for outliers. Definition of outliers can be vague. When we're working on box plots, we do have a rule we use, a formula to find them, and I'm going to walk you through that right here. First of all, find the IQR. Remember, that's the interquartile range. That is Q3 minus Q1. Then we're going to calculate IQR times 1.5. And then we're going to do this. Think about your box and your box and whisker. Q1 is here, Q3 is here. We're going to multiply the IQR times 1.5, and if a data set, let's say it goes to here, let's say if you do it times 1.5, it goes to here. Anything bigger than that passed out here is going to be considered an outlier. Same thing this way. We're going to subtract that value from Q1. Let's say it gives me that, like Q1 minus IQR times 1.5, and I get a value over here. That's going to be an outlier, and we're going to show them a little bit differently. So again, find your IQR, multiply times 1.5, add it to Q3, subtract it from Q1. Anything that doesn't fit, there's an outlier. Kind of like we did our range rule of thumb with the 95%. Those are unusual values or outliers. Okay, modified box plot, it's going to look like this. We're going to use a special symbol for our outliers, usually either a special, maybe an asterisk or something like that, even a big dot or something that just is not connected. The solid horizontal line on our box plot goes only to the max and min. It doesn't make it all the way to the outlier. The outlier stands out there all by itself. Okay, so here's a chart on those Hannaford cookies, the ones that have not as many chocolate chips in them, obviously. And the directions say to make a box plot for the chocolate chips. And what I went ahead and done, just for the sake of time, is went ahead and found first quartile, second quartile, third quartile, so we'd have those ready. Calculated the IQ range. Remember, you do the Q3 minus Q1, which gave me 2.5. And to find our range for see if there's any outliers or not, you do the IQ range times 1.5, and I got 3.75. So what you do with the 3.75 is you subtract it from Q1 to get your lower value. You add it to Q3 to get your upper value, which is 19.25. So I go up here and look at my chart, see if there's anything below 9.25, and there's not, because everything up there is in double digits. I'm looking for anything bigger than 19.25, and I see one. I see that 21 right there, and that's all I see. So there's one, that's an outlier. So what I'm going to do is I'll make my box and whisker just like this. The minimum value was, what is the minimum? It's 11, looks like. My Q1 is at 13. So I'm going to put 13 there. That's where the box starts. And the box is going to go to 15.5. So there's 15.5. My median is a little bit closer to 13. It's 14. And let's see. The max besides the 21 looks like it's 17. So I'm going to put a 17 here. That's the real true end of the box plot. The outlier is 21. So what I'm going to do is I'm going to come out here and put 21 as like an asterisk and put 21. That's the outlier. So that's how you make that box plot with an outlier based on what you've learned so far in the video. All right, this is a great slide. Maybe take a picture of this or something, because this is everything we've done pretty much since we started school. It says we've discussed several basic tools commonly used in statistics when designing an experiment, analyzing data, reading an article or a journal, or doing anything else with data. It's important to consider all these key factors, such as what's the context of the data, what's it about? What's the source of the data? Where did it come from? What kind of sampling method was used? Was it flawed? Was it sound? Was it stratified? Was it clustered? What kind of measures of center are there to use? Are median, mean? Make sure you know what those mean. How spread out is the data? What's the variation? What's the standard deviation? What's the variance? Distribution, what type of distribution is it? Is it a normal distribution? Is it skewed? Are there outliers? Because that affects a lot of things. And have changing patterns over time. We haven't really talked a whole lot about that. We need to do a better job there, because things do change over time. Make conclusions, which we're about to go there before too long. the second half of our statistics course is going to be making conclusions about things, and of course any practical implications from those conclusions is where we're going. So that's a really good slide right there. If you took a picture of stats, there it is. So looks good. I'll see you tomorrow. We'll work on some of this. See you. Bye.